Hello ladies and gentlemen, welcome to my lecture series Introduction to Astronomy and Astrophysics. This is lecture 1, part 2, the history of astronomy. Last time we had finished with Charles Messier, and now we continue with one of the most famous astronomers at all, William Herschel. William Herschel was born in Germany, Hanover, and went to Great Britain later. He built the biggest telescope at that time. That was the reason why he could make a whole series of new astronomical discoveries. Here we see in the picture Herschel's biggest reflecting telescope. It was built in 1789. His most famous discovery was the planet Uranus in 1781. But he also discovered some moons in the solar system. He thought that the Sun is the center of the galaxy. Okay, that was a wrong assumption we know today. At that time it was not known that our galaxy is only one among many others in space. But he thought that there are some other galaxies, and so the Sun would not be the center of the universe. He was the first who assumed the right shape of the Milky Way. He recognized that in double star systems the Newtonian gravitational law is obeyed, like in our own solar system. So in 1779, Herschel recognized that the pole star is a double star. 2 years later, he discovered Uranus as the seventh planet in the solar system. In 1783, he discovered the Tau Canis Major star cluster, that is NGC 2362. NGC means the New General Catalogue. The galaxy NGC 7184 within the constellation Aquarius, and NGC 3274 with the spiral galaxy in the constellation Leo. He discovered the eigenmotion of the Sun. In 1784, he could resolve M56 into stars. He observed the inclination of the Mars axis and its polar regions. Okay, and he discovered further galaxies. In 1787, Herschel discovered Titania and Oberon, moons of Uranus. In the same year, the Eskimo Nebula, NGC 2392, and the Bubble Nebula in the constellation Cassiopeia, NGC 7635. And then in 1788, he discovered that Mars has got an atmosphere. Next year, 1789, he discovered Mimas and Enceladus, two moons of Saturn. In 1790, he discovered an elliptic galaxy in the constellation Virgo, IC 1101. IC, that is the index catalogue. Already in 1797, Herschel obviously discovered some rings of Uranus. But it was supposed as a mistake because that discovery couldn't be verified. 1 year later, he discovered the Fireworks Galaxy, a spiral galaxy, which is found in the constellation Cepheus and Cygnus. Then we have Pierre Simon de Laplace. He lived from 1749 to 1827. He made some studies about the stability of the solar system and he took up Kant's nebula hypothesis. In 1799, he found out that the big half-axis of a planet's trajectory around the Sun does not change. Okay, today, with our precise measurements, we must say the planet's orbits are only quasi-stable. Then in 1800, Herschel discovered the infrared radiation. Then we have the Italian Giuseppe Piazzi. He lived from 1746 to 1826. He was the founder of an observatory in Palermo on Sicilia. He is especially known because of the Palermo catalogue of stars with 7,646 stars. He was the discoverer of Ceres, the biggest asteroid. Firstly, he thought it was a new planet, but Herschel objected that it was very small. Today we know there is an asteroid belt between Mars and Jupiter, and we talk about dwarf planets. The next one is Wilhelm Olbers, 1758 to 1840. He took up Halley's idea of an indefinite universe. He formulated a paradox, the Olbers paradox. He discovered the asteroids Pallas and Vesta in 1802 and 1807. Then we have Joseph von Fraunhofer, 1787 to 1826. In 1814, he discovered some lines in the spectrum of the Sun. So they are called Fraunhofer lines. In 1815, Olbers discovered a comet. It is named after him. Then we have Friedrich Wilhelm Bessel from 1784 to 1846. Because of disturbances in the trajectory, he predicted a companion of Sirius. Bessel, together with W. von Struve, measured the first parallax of a star. It was 61 Cygni. He determined the position of more than 50,000 stars. The next is Johann Franz Encke. He lived from 1791 to 1865. In 1819, he published his calculations of the trajectory of the comet that is named after him, the Encke comet. It was the second periodic comet that was discovered. Yeah, the first one was Halley. In 1823, Olbers formulated his paradox of the sky. Then in 1824, Bessel introduced a new method to calculate eclipses. Still today, we use the so-called Besselian elements. And that was in 1838 when Bessel measured the first star parallax. Then we have John William Draper, 1811 to 1882. It's the father of Henry Draper. He took the first photo of a celestial body, the moon, and then the sun, in 1839. He also improved the photographic processes. Now we reach another era. From now on, photographic recordings were possible. As the next, we have Christian Doppler, 1803 to 1853. he discovered a wavelength or frequency effect that is named after him, the so-called Doppler effect. That means if a sound source and a receiver are moving towards or away from each other, then the wavelength or frequency will change. At the receiver, we measure another wavelength than the source has emitted. In 1842, he explained that the received wavelength or frequency is dependent on the relative velocity. Then we have Friedrich Wilhelm August Argelander. He lived from 1799 to 1875. He is known for a star catalogue of 324,000 positions. He used the 72 mm telescope in Bonn, Germany. So it is called Bonner Durchmusterung. Almost all stars of a magnitude brighter than 9.5 between North Pole and a declination of -2 degrees are included. In 1842, he discovered the high proper velocity of Groombridge 1830. In 1844, there was a first correct prediction of an unseen star. That was Sirius B. Bessel found some disturbances in the movement of Sirius A. The next two scientists are Robert Wilhelm Bunsen, 1811 to 1899, and Gustav Robert Kirchhoff, 1824 to 1887. Those two introduced the spectral analysis in 1846. Then the next is Urban Jean Joseph Leverrier. He lived from 1811 to 1877. Because of perturbations in the Uranus orbit, he could predict the trajectory of an eighth planet in the solar system. And then in 1846, Joan Gell and John Couch Adams discovered that planet, Neptune. Then we have Edward Roche, 1820 to 1883. In 1848, he calculated a limit radius, Roche radius. A moon cannot exist nearer than that radius because the gravitational force of the planet would be stronger than the gravitational field of the moon to hold it together. Then we have George Friedrich Bernard Riemann. He lived from 1826 to 1866. We talk about Riemannian spaces if we speak about curved spaces, but Riemann had not developed the non-Euclidean geometry alone. Some other mathematicians made some contributions like Carl Friedrich Gauss, Nikolai Lobachevsky, or Janus Bolyai. In the 1850s, Riemann developed his theory about non-Euclidean geometry. The next is Norman Robert Pogson, 1829 to 1891. He introduced the mathematical definition of the star's brightness in 1856. Historically, the visible stars were put into 6 classes. Pogson's definition was to say that a star of first order is 100 times brighter than a star of order 6. In 1859, the catalogue Bonner Durchmusterung was published. 3 persons were responsible besides Argelander. There were Adalbert Krüger and Eduard Schönfeld. Here we have Daniel Kirkwood, 1814 to 1895. In 1866, he discovered some gaps in the asteroid belt because of orbital resonances, especially with Jupiter. There are regions with no or only a few asteroids. Then we have the two astronomers, Charles Joseph Wolf, 1827 to 1918, and Georges Pons-Rayet, 1839 to 1906. In 1867, they discovered a new kind of star, the Wolf-Rayet stars. The characteristics are a hot surface temperature and a spectrum of broad emission lines. The next is John William Riley, 1842 to 1919. That was in 1871 when he explained the blue color of the sky. The scattering of light is inversely proportional to the fourth power of the wavelengths. So blue light has got the strongest scattering. But that was not the complete explanation. He was the discoverer of the chemical element argon in 1895. Then we have Edward Emerson Barnard, 1857 to 1923. He discovered Amalthea, a Jupiter moon, the fifth one. In 1892, and later Barnard's star in the neighborhood of our solar system. But he also discovered 15 comets and published a catalogue of 370 dark nebulae. In the second half of the 19th century, astrophysics was developed gradually out of astronomy. Now we reach the 20th century. As the first, we have Albert Einstein. He lived from 1879 to 1955. He formulated the so-called cosmological principle in 1931. That means that all places in space are equivalent. Our position in space is not a special one. Most known are the two works, the theory of special relativity in 1905 and of general relativity in 1916. He won the Nobel Prize for the theoretical description of the photoelectric effect. Then Henrietta Swan Leavitt, 1868 to 1921. Together with Shapley, she found out that there is a relation between the period and the brightness of Cepheid stars. Cepheids are variable stars. They vary in the brightness. In 1908, she published her results. The brighter a star, the longer is its period. The next three persons are Henry Norris Russell, 1877 to 1957, Edward Charles Pickering, 1846 to 1919, and Williamina Patton Stevens Fleming, 1857 to 1911. They together discovered the first white dwarf in 1910. That was 40 Eridani b. In 1912, Leavitt presented the exact relation between period and brightness of Cepheids, so that it could be used to determine distances. In 1913, Ejner Hertzsprung, 1873 to 1967, and H. N. Russell developed the Hertzsprung-Russell diagram. There we find the distribution of the stars of a galaxy dependent on the effective temperature and luminosity. So here we have a sketch of a Hertzsprung-Russell diagram. In the diagonal we have the main sequence. Then above here we have the red giants, and for example in the left lower corner here there were the white dwarfs. Yeah, okay. 1916, Barnard discovered a star with a fast proper motion that is called Barnard's star. It's the second nearest after the Centauri group. Same year, Einstein published the work of general relativity. Then we have Karl Schwarzschild, 1873 to 1916. In 1900, he tried to measure the curvature of space. Still, in 1916, he derived a static, spherically symmetric solution of the Einstein-Riemannian field equations. Still in the same year, he died because of an infection. Then Harlow Shapley, 1885 to 1972. In 1918, he recognized that the Sun is not the center of our galaxy. The distance is about 30,000 light years from the center. If we want to observe the center, we must look into the direction of the constellation Sagittarius. In the same year, Shapley used Cepheids to determine the size of the Milky Way. Then we have Hermann Weyl, 1885 to 1955. In 1918, he supported the general theory of relativity. He wrote a book, Space, Time, Matter. Then here we have Henry Draper from 1837 to 1882. Between 1918 and 1924, the Henry Draper catalog was published in 9 volumes. There were the spectroscopic classifications of over 225,000 stars. Then between 1925 and 1936, an extension was issued with further more than 46,000 stars, and between 1937 and 1949, another extension with further almost 87,000 stars was published. Draper had already died, but it was named after him because there was published a Draper catalog of stellar spectra with over 10,000 entries after his death in 1890. The next two are Alexander Friedmann, 1888 to 1925, and Georges Lemaitre, 1894 to 1966. Between 1922 and 1927, they derived solutions for the Einstein equations to describe the expanding universe. We speak about Friedman equations or Friedman universe. Then we have Carl Charlier, 1862 to 1934, to solve the Olber paradox. He proposed to enlarge the distances between the objects in the hierarchical model in the 1920s. Then we have Edwin Powell Hubble. He lived from 1889 to 1953. And that was in 1924, about when he found out that the nebulas in the sky are other galaxies. He could identify the Cepheid stars in the Andromeda galaxy, and he could prove the expansion of our universe by measuring the redshift of faraway galaxies. Yes, in 1923, Hubble discovers a Cepheid variable star in the Andromeda Nebula. And in 1924, he could confirm that the so-called nebulae are indeed galaxies and far away than the stars in our own Milky Way. In 1926, he introduced his classification of galaxies that is still in use today. Then we have Jan Hendrik Oort from 1900 to 1992. He made measurements of the position of our solar system in our galaxy. And so he could confirm Shapley's observation. And he postulated the so-called Oortschen cloud, where the comets shall come from. Yeah, that was in 1927, as Oort could determine the rotation period of our Milky Way, and then it wasn't so clear that our galaxy is rotating around its center. And he could confirm the theory of Lindblad, who supposed that before. In 1929, Hubble measured the recession velocities of some galaxies by using the redshift. Redshift is the Doppler effect in the visible light. And so he found out that the velocity increases with the distance. And so this is called Hubble's law. Although Lemaitre had found that 2 years before. The next one is Subramanian Chandrasekhar. He lived from 1910 to 1995. It was in 1930 as Chandrasekhar found out that a star with over 1.4 sun masses cannot become a white dwarf because the electron gas pressure is too weak to resist the gravitational force, and so there would be another gravitational collapse. Okay, then if we have a higher mass than 1.4 sun masses, then the star would become a neutron star then after the collapse. The next is Clyde Tombaugh, 1906 to 1997. Yeah, besides Pluto, Tombaugh discovered 15 asteroids. And that was in 1930 when Tombaugh discovered Pluto as the 9th planet at that time. Then Willem de Sitter, he lived from 1872 to 1934, and in 1932, de Sitter, together with Einstein, developed a model for an expanding universe. And the so-called de Sitter universe had some special properties. Here, the light is the more redshifted, the longer the way it has to our Earth, to the observer. Then Fritz Zwicky, 1898 to 1974. In 1933, he made some calculations for galaxy clusters. He used the virial theorem, and that led to the postulation of dark matter later. Then the next, Walter Baade, 1893 to 1960. Up to the 1950s, there were some problems by measuring the distances to other galaxies. Baade made then a difference between population 1 and 2 stars. And so there were then two kinds of Cepheid variables. That was in 1942. And so it was possible to correct the distances to the galaxies. And suddenly they were then twice as far away than before. Furthermore, he discovered 10 asteroids and some objects visually that were only known as radio sources before. Then we have Carl Gus Jansky from 1905 to 1950. He's one of the founders of radio astronomy. He was a radio engineer at the Bell Laboratories, and there he built a directional antenna. And that was in 1933 when Jansky discovered radio waves which come from the Milky Way, or more exactly from the constellation Sagittarius. He built a big movable antenna for radiostatic measurements in 1931. And so he could detect radio noises from the space. Then we have Claude Reber. He lived from 1906 to 1997. In 1937, he, as a radio engineer, built the first radio telescope that was in Wheaton, Illinois. And there the result was the first radio map of the Milky Way. The next one is Hans Albrecht Bethe, 1906 to 2005. He explained in the 1930s how the sun produces its energy. In 1967, he received the Nobel Prize for his work on stellar nucleosynthesis. In 1939, he published a work in which he explained the CNO cycle as an energy source of a star. Then 1942, James Stanley Hay, 1909 to 2000, he discovered the radio radiation of the sun. Year later, 1943, Carl Keenan Seyfert, 1911 to 1960, he described a new kind of galaxy that is named after him. But already in 1908, E.A. Fath and V. Sliver had observed such Seyfert galaxies at the Lick Observatory. And in 1926, E. Hubble observed NGC 1068 and its spectrum. Here the center of the galaxy is very bright and it emits unusual much electromagnetic radiation. Seyfert galaxies show strong emission lines of ionization. Then in 1948, the mirror telescope with a 5.08 mirror at the Mount Palomar started its operation. At that time, it was the largest mirror telescope in the world. In 1950, Oort proposed a cloud of comets with a very long period, about 1 light year away from the Sun. This is what we call today the Oortchen cloud. Then we have Gerard Kuiper, 1905 to 1973. In 1951, he conjectured that there could be another asteroid belt beyond the trajectory of Neptune. That is what we call today the Kuiper belt. 1 year later, 1952, Baird presented a classification of population 1 and population 2 stars. Another year later, 1953, Shapley introduced the concept of a liquid water belt. That is what we call today the habitable zone. The next one is Kenneth Franklin, 1906 to 1997. In 1955, he, together with the other American astronomer Bernard F. Burke, 1928 to 2018, they discovered the radio radiation of Jupiter. Now, in the middle of the 20th century, a new era began, the space age. From now on, it was possible to send space probes into space, and so many new discoveries in astronomy were possible. So the first we have, that is Explorer 1, launched on February 1st in 1958. This probe discovered the Van Allen radiation belt. Then Luna 3 launched on October 4th in 1959. In that year, the space probe was taking the first photos of the dark side of the moon. Then we have Frank Donald Drake. He lived from 1930 to 2022. In 1960, he founded the first SETI project. that was called OSMA, SETI, the Search for Extraterrestrial Intelligence. And the next year, 1961, Drake published the so-called Drake equation. With that equation, it is possible to guess how many intelligent species do exist in space, perhaps. In the formula, there are many probability factors. Then we have Mariner 2, launched on August the 27th in 1962. The probe measured the solar wind, dust, and the magnetic field of the Sun, and on its way to Venus, the cosmic radiation. Then in 1962, Mariner 2 reached Venus, and there it measured cool clouds and a very hot surface. And the atmosphere of Venus contains much carbon dioxide and is very hot. And it is also optically thick. Then we have Martin Schmidt from 1929 to 2022. In 1962, Schmidt discovered the very first quasar. That was 3C273. That was a radio source without optical light. Then the next two scientists are Arno Allen Panzias from 1933 to 2024 and Robert Woodrow Wilson. He's still alive. He was born in 1936. In 1963, Panzias and Wilson discovered the cosmical background radiation. This radiation lies in the microwave range of the electromagnetic spectrum. The temperature equivalent is 2.7 Kelvin. So that means the temperature of the universe is 2.7 Kelvin. That was a proof for the isotropy of space, because there is no preferred direction of that radiation. But more important, it is a proof for the hot Big Bang hypothesis. As the hot Big Bang took place, there was a giant temperature of our universe. But because of the expanding movement, it has been cooling down, obviously, to 2.7 Kelvin now. Then we have Ranger 7, launched on July the 28th, 1964. It was sent to the moon. Here we see a picture of that probe, of the moon surface. In 1964, the probe was taking over 4,000 very good pictures of the moon's surface. The very last photo had a resolution of 50 centimeters, and then the probe crashed onto the surface of the moon. There was no controlled landing. Then the next, Mariner 4, launched on November the 28th in 1964. With Mariner 4 there was a first flyby of planet Mars then. And there it took the first close-up photos of the surface of Mars. But here then many scientists were disappointed because what they saw was only a stony, sandy surface, and there was obviously no life. Before, there was a great hope that there is life on Mars, but that was the first hint that there is no life on Mars. Then 1 year later, Mariner 4 sent some data which shows an atmospheric pressure of 4.1 to 7 millibars and a temperature of about minus 100 degrees Celsius during daytime. And so, Mars has got a very thin atmosphere, and there is no magnetic field, and there is no radiation belt like the Van Allen belt at the Earth. And no water was found on the surface. The next space probe is Luna 9, launched on January the 31st in 1966. Here we have a picture of the moon's surface. In 1966, Luna 9 performed the very first soft landing on the moon. We got the first picture from another celestial body at all. It means from directly on the surface. Then here we have Susan Jocelyn Bell, born 1943, still alive. In 1967, Bell was in the research group of Anthony Hewish, and she discovered the first pulsar. That means neutron star. As they measured the regular pulses, they didn't know that that was a neutron star. Then we have the space probe Venera 4, launched on June the 12th, 1967. In 1967, it made the measurements of the Venus atmosphere. So, the result was that the main part of the atmosphere is carbon dioxide. Then we have some nitrogen and a little oxygen. Venus has got a weak magnetic field, and the very last transmitted data of that space probe showed a temperature of 270 degrees Celsius and a pressure of 22 bar, and that in a height of 25 kilometers from the surface. Then 1969, the astronaut of Apollo 11 brought back rocks from the moon. And they set up a laser reflector on the surface, and that allows a very exact determination of the distance between Earth and Moon. From that point in time, we know that the Moon is moving away from Earth about 4 centimeters a year. Then we have the two space probes, Mariner 6 and 7. They were identical. They were launched on February 25th, 1969 and March the 27th, 1969. Here we have a picture of two pictures of Mars. That was then in 1969 as Mariner 6 and 7 detected a Mars atmosphere again. That consists mainly of carbon dioxide. And now some water was found on the surface, but not so much. The moon Phobos was on one of the pictures from Mariner 7. Here we saw firstly its very irregular structure. Then we have the Uhuru X-ray satellite. It was launched on December the 12th, 1970. In the 1970s, that satellite scanned the sky to find X-ray sources. And there is a For You catalog which was issued then, and it contains 339 objects, X-ray objects. Then we have Mariner 9, launched on May the 30th in 1971. That was the very first space probe which moved into an orbit around another celestial body. In 1971, Mariner 9 was taking photos again from over 70% of the surface of Mars. That was the highest resolution until then. We got over 7,000 photos from Mars. And the photos they showed kind of riverbeds, craters, canyons and volcanoes. The very big canyon is the Valles Marineris, and the highest volcano there is Olympus Mons. It's the biggest volcano, the highest volcano in the solar system. In 1972, because of the Uhura space probe, Uhura satellite, a black hole was assumed in the constellation Cygni X1. Then here we have Pioneer 10, launched on March the 3rd in 1972. In 1973, Pioneer reached the planet Jupiter in November 1973. We got detailed photos of Jupiter and several moons for the first time. There was no other space probe there before at Jupiter. Now Mariner 10 launched on November the 3rd in 1973. It was the first space probe which made a flyby at two planets, Venus and Mercury. Here we have a picture of Mercury. For a long time that was the best picture we had of Mercury. In 1974, Mariner 10 was taking about 9,000 photos of about 45% of Mercury's surface. The next is Venera 9, launched on June the 8th, 1975. Here we have a picture of the surface of Venus from that probe. That was in 1975 when that probe sent, besides other data, the first image from the surface of Venus. But the space probe didn't work very long because of the heat in the atmosphere and the pressure. Then we have Viking 1 and 2, launched on August the 20th and September the 9th in 1975. Those were two identical space probes. And in 1976, the two Viking space probes landed softly on the surface of Mars. That was the very first soft landing there. And so they took the very first photos from the surface of Mars and sent them to Earth together with other data of Mars. Yes. Then James Walter Christie, born 1938, he discovered the Pluto's moon Charon at the US Naval Observatory. The next are the Voyager probes, Voyager 1 and 2. They were launched on September the 5th and August the 20th in 1977. Then in 1979, the two identical Voyager space probes reached Jupiter. And their Voyager 2 took photos of some moons like Amalthea, Io, Callisto, Ganymede and Europa. 9 volcanoes were observed on Io, which had an eruption. 3 new moons were discovered, Atrace, Metis and Tibi. Then in 1979, Pioneer 11 launched on April the 6th, 1973. It was built similar to Pioneer 10, and it reached planet Saturn and took detailed photos of the planet for the first time. Then 1980, Voyager 1 reached Saturn. The photos were spectacular. There were very detailed recordings of the rings. Much was revealed about the inner structure of the rings. And Voyager 1 showed that the atmosphere consists of mainly hydrogen and then about 11% helium and then other gases. The wind velocities were measured and the rotation time of Saturn. Titan, the biggest moon of Saturn, was observed intensively. And some other very good photos of other moons were transmitted to Earth. Then in 1981, Voyager 2 reached Saturn. It also gathered data of the upper atmosphere, and it took many pictures as well of the planet itself, moons, rings. Then we have the infrared astronomical satellite, IRAS. It was launched on January the 25th in 1983. The problem is we cannot observe in the infrared range in the electromagnetic spectrum on the surface of Earth because the atmosphere absorbs the infrared radiation. And so here we have an infrared satellite and made a survey of the sky of 98% in the infrared. Then 1986, Voyager 2 reached Uranus. And here 11 new moons were discovered. Much data were sent to Earth about the atmosphere. Some photos were made of the planet's ring. Then in 1986, the European space probe Giotto reached Comet Halley. Here some measurements of the emitted material were made and some photos were taken of the nucleus. In 1989, Voyager 2 reached Neptune. Here it discovered the ring of the planet and 6 new moons, and yes, the probe made some measurements. Here we have the space probe Magellan, launched on May the 4th, 1989. In 1990, that probe reached Venus, and it yielded a 96% coverage of the surface of Venus. It measured the surface gravity there. Then we have the famous Hubble Space Telescope. It was launched on April the 24th in 1990. But the problem was there was a constructional defect, and so a space shuttle mission was launched in 1993, and some optical corrections were installed to compensate the optical error. And then, the Space Telescope could start its work, especially because of Hubble's position outside the atmosphere. It could take unique photos, especially from the deep space. Then here we have the space probe Galileo. It was launched on October the 18th in 1989. In 1995, that space probe observed Shoemaker-Levy 9 as it crashed into the atmosphere of Jupiter. The next two are Michael Mayer, born in 1942, and Didier Queloz, born in 1966. They discovered the first exoplanet. That was 51 Pegasi b, or they are also called extrasolar planets. Then in 1995, the Galileo space probe reached Jupiter and went into an orbit around the planet to observe the Jupiter system for a longer time. It was the first time that the space probe goes in that orbit. Then in 1997, 2 new Uranus moons were discovered. Then in 1997, 2 new Uranus moons were discovered. That was done by the Hale telescope of the Palomar Observatory, California. These 2 moons are called now Sycorax and Caliban. Then the next 3 scientists are Saul Perlmutter, born 1959, Brian Paul Schmidt, born in 1967, and Adam Guy Rees, born in 1969. Yes, there were 2 teams, the Perlmutter team and the team of Schmidt and Rees. They made measurements of the distance of supernova 1A events. And then it turned out that obviously the expansion movement of the universe is accelerated and not decelerated. That was supposed before because of the attraction force of gravitation. Okay, for that discovery, they won the Nobel Prize in 2011. Then in 2002, Brown and Trujillo discovered the dwarf planet Quaoar. Yeah, it's an object of the Kuiper belt. And in the same year, Brian A. Skiff discovered Zoozve. Yeah, it is moving around the Sun and has got nearly the same orbital period than Venus. Then 2003, again Brown, Trujillo and Rabinowitz discovered the dwarf planet Sedna. Yeah, also a body of the Kuiper belt. And next year, the same three discovered the dwarf planet Orcus. Yeah, object of the Kuiper belt. Then we have the Cassini-Huygens space probe. It was launched on October the 15th in 1997. And in 2004, the space probe reached Saturn. 7 new moons were discovered there. Those were Methone, Pallene, Polyteusis, Daphnis, Anthe, Aegeon, and S2009 S1, and additionally a moonlet. Then in 2005, the trans-Neptunian object Eris was discovered. Yeah, again by the group Brown, Trujillo and Rabinowitz. Firstly, they thought it could be a 10th planet, but then they recognized that it is an object of the Kuiper belt like Pluto, though it is a dwarf planet, no real planet. In the same year, the space probe Huygens landed softly on Titan. And though there were the first photos from the surface of Titan, the probe made measurements of the atmosphere from altitude of 1,400 kilometers to the surface. And so we know there are strong winds on Titan. Yeah, the atmosphere has got much nitrogen, like here on Earth. Yeah, that's the only planet or body in the solar system which has got much nitrogen in the atmosphere besides Earth. Then in 2006, Pluto is no planet anymore, because there were found many objects beyond the Neptune trajectory since 1992. So the International Astronomical Union declared Pluto then as a dwarf planet and as an object of the Kuiper belt. There is another kind of asteroid belt beyond Neptune. Pluto is only one object of others here. Then we have the Dawn space probe. It was launched on September the 27th in 2007. And in 2011, it reached the asteroid Vesta. Geological map of that asteroid could be compiled with the data which Dawn yielded. In 2013, there was the discovery of the first extrasolar asteroid. That was at the white dwarf GD61. It carries liquid water and water ice. Then 2015, the space probe New Horizons reached Pluto. 2 new moons were discovered, Kerberos and Styx, and the space probe collected some data from Pluto and his other moons. And in the same year, the space probe Dawn reached asteroid Ceres. Then 2016, at Proxima Centauri, an exoplanet was found, Proxima Centauri b, by the European Southern Observatory. And now this is the nearest exoplanet that was found until now. 2017, there was a neutron star collision in the galaxy NGC 4993, and that was observed. So gravitational waves could be measured by LIGO, that is the Laser Interferometer Gravitational Wave Observatory in Hanford, Washington, and another facility in Livingston, Louisiana, USA, and Virgo, that is in Santo Stefano, Macerata in Tuscany, Italy. Now, at the moment, there is a kind of race to discover the first exomoon. Now we finished lecture 1. Next time in lecture 2, we will look at our position on Earth in space and what we see in the sky, especially in the night sky with the stars. So thank you for watching. See you next time. Goodbye.